Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication Engineering at MLR Institute of Technology. So today's presentation is about how to program timers and counters of 8051 microcontroller. So the overview of today's presentation is what are the steps that we need to follow while programming the timers and counters of 8051 and how to program different modes by using different programming. Coming to the steps that we need to follow, first of all we need to set the T mode register. So what is the T mode register? This video is a part of series microprocessors and microcontrollers. If you want to know what is the T mode register and how to set the values of T mode and timers, do watch the previous video. And the T mode register is a timer mode control register which says that which timer is need to be taken and in which mode that timer is to be working. So there are two timers, timer 0 and timer 1 in 8051 microcontroller, and those two timers are of a 16-bit timers. So we can use the two 16-bit timers by splitting 8-bit in timer 1 and timer 0, and it can work in three different modes of operations: mode 0, mode 1 and mode 2. So mode 3 is also there, but we are not using those in 8051. So we are using these three modes of operation in 8051. So to select which timer, whether we are selecting timer 1 or whether we are selecting timer 0, and in these timers which mode we are using. So it always depends upon the value that we are setting in the timer mode, right? Yes. Next, coming to the next one, next step, we need to load the delay values in TL and TH of those timers. If we are using timer 0, the values are TL naught and TH naught. It always, you need to calculate before keeping the values in TL and TH registers. So if we are using timer 1, then the values needed to be loaded into TL1 and TH1. So now after setting these two values, after giving the T mode value and TL and TH value, then only we need to start the timer. So after starting the timer, the timer flag continuously checks whether it is having the overflow concept. As I already told you, if the timer reaches the maximum time count, then it will get back to the least count. So that is nothing but the rollover case or rollback case, that is also known as overflow flag. So if that timer overflows, then we are completing the delay time which we are given in the TL naught and TH naught. So that is to be checked by using the instruction JNB, jump if no bit is there. So if the timer flag is not having any bit, then the target will be repeated. If we are fetching any bit in the TF, so if TF flag is 1, then overflow is happened, so flag, the delay is completed and we need to stop the timer. So after getting the 1 in TF flag, we will stop the timer, and as the timer stops, we need to clear the flag register also, that corresponding to the timer. If we are using timer 1, the TF1 will need to be stop. If we are using timer 0, TF naught will get stopped. Okay, so this loop will be executed until the TH and TL values delays that we have given in the timer. So this is continuously repeated. This is how we will write the programming for timers and counters. Let us see three different cases by using three different modes of operation. So here the programming in mode 0, as I already told you that the mode 0 is of 13-bit timer. So the maximum size of this 13-bit timer is 1 triple F, right? So we need to calculate before writing the program. We need to calculate how we will be writing T mode values and how we will be calculating TH and TL values. So first of all, we need to write the T mode value, right? So here the T mode is a 8-bit register. So the first 4 bits will be for timer 0 and the next 4 bit is for timer 1, right? Yes. So here they have mentioned write a program to create a delay of 25 microseconds. We need to create a delay program for 25 microseconds using timer 1. So here timer 0 is all values are zeros. The first one is gate and the second one is counter or timer, and the third one is M1 and M0, which is used to select the mode. Here the mode is 0 and gate bit always be 0 because we are using it in the software. If we hardware is utilized, then we will keep gate bit as 1. But here we are writing the program, so software is used. So we need to keep it as 0. Right. Next one is C by T bar, which is whether we are using this counter and timer unit for counting purpose or timer purpose. Here they have specifically mentioned that we are using timer. So to get timer over here, we need to keep it as 0. And mode 1 and mode 0. Mode 1 and mode 0. If those two are 0, we will be selecting mode 0. If those two are 0, 1, mode 1 will get selected, and 1, 0, mode 2 will be get selected. Here they mention that it is a mode 0. So those two values are all of 0. So what is the value we need to keep in T mode register? 0000 means hexa equivalent 0, and all zeros means hexa equivalent 0. So the T mode register that we need to fill is 00H. So keep it aside that move T mode equals to 00H. Sorry. Move T mode, comma 00H, hash 00H to represent it is a value. Right. Now we need to calculate the T here timer 1. So TH1 value and TL1 value. So how to calculate the timer values? Before calculating the timer values, make sure that one machine cycle requires 12 clock cycles. So in timer, if we want to find out the time period of a timer, we need to first know the frequency of the controller, and then from that frequency we need to find the time period of the controller, and then we need to find the time period of one time period of the timer. So here, as we all know, that the crystal frequency of controller 8051 is 11.0592 megahertz. This is precisely accurate exit. Sometimes they will consider 12 megahertz, but while we are doing crystal frequency, the 8051 works on 11.0592 megahertz. So that's why we need to take this one. So from here, I need to find out the timer frequency. So what is the timer frequency? So one machine cycle requires 12 clock cycles. So here timer frequency can be calculated by dividing the crystal frequency by 12, because 12 clock cycles are required. So what is the value? Which is equals to 0.9216 megahertz. Right? Yes. Here we find that it is the frequency. But what we need to know? We need to know time period of the timer. So time period of timer is equals to, as we all know, that frequency reciprocal is the time, right? So 1 by F. So equals to 1 by 0.9216 megahertz, which is equals to 1.085 microseconds, right? So 1.085 microseconds. We know that for one we are having 1.085 microseconds, but for one cycle. But how many cycles are required? So we need to produce 25 microseconds. So we need to find what is the value of this X. So how can you find out? By using X equals to 25 microseconds into 1 by 1.085 microseconds, right? So these microseconds will get cancelled. And what is the value over here? The value is 23.0414. But this is in the format of decimal number. So we need to find out what is the value of X. X equals to 25 microseconds divided by into 1.085 microseconds. So what is the value here? 23.0414. But this is in the format of decimal number. So I am taking the value equivalent to 23. So we need to convert the decimal number into the hexadecimal number. So what is the equivalent hexadecimal number for the decimal number 23? It is 17. So 17 is the decimal equivalent. So here now I need to calculate the values of TH1 and TL1. So how we will calculate? So we need to subtract this number from the maximum size of the timer. So here the mode is mode 0. So maximum size of the timer is 1 triple F. So we need to subtract it 17 from the maximum size. So what is the value? Here F means 15, 15 minus 7 it is 8 and F minus 1 it is E. So F and 1. So the lower byte E8 will be loaded into the TL, lower byte of timer 1. So the lower byte TL1 will be loaded with the E8 and the higher byte TH1 will be loaded with the 1F. So now we know that the value of T mod register and the second step the value of TL registers, right? TL and TH registers. Now after loading this we could start the timer. We will wait for the overflow flag and now it is all set. So how to write the program using these values? Let us see. So this is the program. We are just starting with the program started with the 0000 location. Here, as I already told you that we found that T mode is 00H and TL value, TH value as here. This is the values E8 and 1F. So that values has been loaded. Now, so in question they make sure that write a program to create a delay of 25 microseconds. We have done in timer 1 mode 0 done, and here blink all the pins of P2. So P2 pins should be blinked, and after completing that 25 microseconds it need to be stopped, and after 25 microseconds again it need to be blinked. So this is the continuous process. So 25 microseconds, after 25 microseconds this pin will need to be blink, on and off will be done. So that's why here the port, first of all the port values are initially input values, input port will be there. So all the values are FF. So that's why we are making the port values as 00. So all of them are 00 condition. Now here we are creating a subroutine that a call, absolute call delay. Delay is the subroutine we've been calling. So after finding this instruction, the controller moves to the delay. So what here we are doing, here we are already these two values, T mode values have been loaded and TL and TH values have been loaded. So now what we need to do, we need to on the timer. So that's why here timer 1 using, so set bit TR1. So in the T mode register, so TR1 bit will be TCON register, TR1 bit will be on. So timer 1 will be on. Now we need to check for the overflow flag. So that's where we are using this instruction JNB TF1 here, right? So if we didn't find any, so no bit is there, the loop will be executed here itself, right? So again and again after completion of the delay, so the timer value will be overflowed. So then TF value will become 1. If TF value become 1, this condition will not satisfy, right? J and B, jump if no bit is there. So if TF1 is equals to 1, bit is there. So this condition will not be satisfied and it will move to the next one. So what is the next one? Clear TR1. As I already told you in the steps that after finding the overflow flag, first we need to off the timer and we need to clear the timer overflow. So that's why here clear TR1. So timer 1 will be off here and clear TF1. So here timer flag will be cleared and return. After finding the return instruction, it will be moved to the next instruction over here. So what is the next instruction? Move P2 comma FF. So all the pins in port 2 until now is 00. So off condition. Now what we are doing, FF means we are making them on. So off and on, and the delay produced over here is 25 microseconds. So this is how we will be writing programming timer 1 in mode 0. Okay, let us see in mode 1 how we will write the program. So this is the question depending upon the timer, and write a program to create the delay of, we need to create the delay of 37.5 milliseconds using timer 0. Here timer 0 is using, and we need to use mode 1. So the maximum size of the mode 1 is full mode. So it is 16-bit mode. So the maximum size is all 4Fs, right? So here also the same steps will be performed, but the values loaded into T mode and TH and TL values will be differ. So first of all, we need to find out the T mode and T1 values. So what is the value of T mode? Here we are using timer 0. All the timer 1 values are 4 zeros, right? Now in timer 1, the first one is gate, it is 0, and we are selecting it as a timer, it is also 0. Next one is M1 and M0. So here we need to select mode 1. What are the values we need to load into M1 and M0? Here we need to load the values of 0 and 1, right? So what is the final hexadecimal equivalent of this binary? So all zeros means 0, this is 1. So what is the value we need to load? In T mod we need to load 01H. So move T mod comma hash 01H. So now the first step has been done. So we need to find out the TH and TL values. Here we are using timer 0. So TL0 and TH0 values we need to find out. The same regular procedure. So as we all know that frequency of crystal oscillator is 11.0592 megahertz. So we need to find out the timer's frequency. So what is the timer's frequency? So crystal frequency divided by 12. So it is equivalent to 0.9216. So 0.9216 megahertz. So from this is the frequency. So I need to find out the time period of timer. So it is 1 by 0.9216 megahertz, right? So it is equivalent to 1.085 microseconds. So fine. So now for 1, we are having 1.085 microseconds. So we need to find out how many delay we need to find out for what is the given 37.5 milliseconds. So how to calculate? So what is the x value? X value is 37.5 into 10 to the power of minus 3 by 1.0 into micro means 10 to the power of minus 6, right? So it is, what is the equivalent value? The equivalent value is 34562.2. Okay. So but this is in the format of decimal. So we need to convert it into the hexadecimal. So what is the hexadecimal equivalent? 8702. You do find out how to find out the decimal to hexadecimal. So we got that 8702 is the hexadecimal equivalent. So we know that. So by subtracting the value of this from the highest value of the timer, in mode 1 the highest value is 4F. So we need to subtract 8702. So here F is 15, 15 minus 2, 13, 13 means what is the value? The value of here is 13 means D, F minus 0 same F, F minus 7, 15 minus 7 is 8, and here F minus 8 is 7. So we need to load TH0 as 7, 8 and TL0 as FT. So these two steps has been done. We know the value of T mod register and we know the values of TH0 and TL0, right? So it is easy to write the program using timer 0 in mode 1. So this is the program. C 01H loaded, FD and 78H. Now we are here they mention port 0. So that's where we've been taking port 00. So in delay the same steps will be repeated. The main two things that we need to make sure before writing the programming timers is what is the T mode value and what are the values loaded into TL and TH value. It always depends upon the timer that you are taking and in which mode that particular timer is working, right? Right. So coming to the next one, how to write the program in mode 2. So as you all know that mode 2 is a 8-bit auto reload mode. The maximum size of it is FF, right? So what is the value of T mod that we need to fill? Here what is timer 0 has been taken. So the timer 1 values, all 4 bits of timer 1 is 0 and first 2 bits, this is the gate bit that we are using the programming. So that's why we are taking it as 0 And next one is C by T bar. Here we are utilizing this unit as the timer, that's why I'm taking 0. And next one is M1 and M0. Here mode 2 has been selected, so to set it in mode 2 we are taking 10. So what is the equivalent of this binary? 0, and this one is 2. So what is the value we need to load into T-mod register? So we need to load T-mod register with hash 02H, right? So move. Yes, we find out the T-mode value. Now we find out the TH value and TL value. But in this case, the mode is mode 2. So in mode 2, only 8-bit auto reload mode. So only one register is used out of 2 registers of the timers. So here we will be loading TH value. So every time the value of TH will be loaded into TL automatically by the controller, right? So here we need to find out the TH value. So what is the TH value? Let's see. So as usual, we know that for one cycle we require 1.085 microseconds. Here we need to find out how many for given. What is the value? 50 microseconds. So what is the value of x? 50 microseconds by 1.085 microseconds. So which is equivalent to 46.08 in decimal number, or precisely we will take 46. What is the equivalent decimal number? 46 equivalent hexadecimal number. The value of equivalent hexadecimal number is 2e. Okay, so as we all know that the highest size of the mode 2 is FF. So we need to subtract the 2e from FF. So what is the value? F is 15, E is 14. 15 minus 14, it is 1. F is 15 minus 2, it is 30. So the value is D. So this value is loaded into the TH register, but here the timer is 0, so TH not. That's it. So we know the value of T-mod register and we know the value of TH not register. Now let's start the writing of the program. So the first one we did load it as T-mod register. In the previous I have already told you what is the value, 02H. That's why we are loading 02H and the value is D1. So here no need to write TL value because automatically 8-bit controller timer will be loaded TL not value with the TH not value, right? Yes, same procedure will be done from like the first programming. So the main thing is we need to load Tmod and THTL values into the register. So now we need to start the timer. We need to check for the overflow flag. If overflow flag enables, then we need to clear the timer and we need to clear the flag. And this procedure will be repeated unless we disturb the controller, right? Yes. Until now, I have discussed how to write the programming and what are the steps we need to follow to write the programming in timers and counters unit of 8051 in mode 0, mode 1 and mode 2. Right? Yes. Thank you.